Oh man. When we do hypergraph hours on Wednesday, I really think that like needs to be the start of the weekend. It's like so much prep goes into all of this, so much energy, so much marketing, so much momentum. Um, there's like so much excitement too. I think of these things as like Christmas Day. Every hypergraph hour is like Christmas Day. Well, before we begin, a huge shout out to GeoJam for getting listed on Binance US yesterday. Really exciting to see the ecosystem come together, everybody kind of working at relationships, networks to in different ways, which all just kind of feeds back into Constellation's ecosystem. And I think that's kind of the exciting thing that we wanted to come out of watching early applications build at Constellation, for them to kind of express their app, their vision in Web3 and see what kind of traction or network effect they can create. So really awesome to see Binance US pick up GeoJam, pick up their vision. It's such an early stage in their app development. They also released, we did a hypergraph hour with them last time, talking through a lot of their new application, what this means. And it's really cool to see, 4 years ago, we wouldn't have seen applications come out like this or attempt to kind of bridge or the Web 2 world with Web 3. And it takes a special group of entrepreneurs to really realize that. So let's kick this off today. After that intro, today is Hypergraph 48. That is 10 years older than I am. So I'm excited about today. We haven't done a technical talk in a long time. This to me is really kind of the preamble to what's to come in 2023. A lot of deployments, a lot of software deployments, hardware deployments, all coming out. And really today is to kind of align our community and what they can expect for 2023. And so I'm here today with Alex and Ryle. Alex is our head of engineering on the product deployment side. Ryle is our director of protocol engineering. And these guys are working together every day to mix and match technology to help each other kind of realize the roadmap and apply the roadmap and products to end solutions. But before I hand it over to Ryle, kind of wanted to set the stage. So about a few months ago in July, I wrote a piece from the CEO on kind of my perspectives on solving the blockchain trilemma. This is a lot around composability with Web 2 and Web 3, but ultimately I took a perspective of talking about our design decisions at the core of Constellation and why we did what we did in building out our network and building out the vision of Hypergraph. And today is really that follow-on. It's a follow-on from the CEO's perspective to the technology perspective, and really the core design decisions that we've made on the protocol and why that matters for today and for the future of applications that are building on Constellation. So without further ado, I'm going to hand it over to Ryle to really start to paint that picture around what I talked about was the protocol, the FAT protocol dilemma. And Ryle actually planted this seed back in 2018 when he talked with Wyatt at TechCrunch. And I think this is a rather new vision that we planted a long time ago, but I think it's going to be really important to hear at the base of our core design decisions on why we started tackling the FAT protocol inversion. So Ryle, I'm going to kind of hand it over to you. And I'll try my best to slow you down and add clarity or ask questions. But really, this is kind of your moment to really talk to the community about the design choices that you've made.
Sure. Thanks for that. So, I think this has been discussed in a couple of different places where, people have made this observation. I think it's sort of obvious if you look at most of the existing platforms that they don't share sort of, the same commonality with what you would expect from, the early internet protocol. I think most of these things, Ethereum and most of the other platforms that offer code execution, in contrast with Bitcoin or other, pure currency operations, things that are targeting Web3, they're typically capturing so much of the value in the platform itself that the application layer is a lot, is sort of left out. I think if you look and think about what most of these platforms offer, they're essentially offering, code execution environments with a very, very strict SDK where you can't actually sort of break outside the bounds of that in a lot of different ways. I think this is, part of the reason where, when somebody is trying to create some sort of new application that offers some kind of new functionality, a lot of the time it's actually easier for them to essentially modify the entire protocol. I think we've seen sort of a lot of nice features in the development of different executors across some of these different platforms. You look at any of the Rust or the WASM protocols that add in extra or additional functionality, and they're sort of going in this general direction of opening up the platform or protocol more so the application can do more things. But I think this sort of general policy we see of most of the value being captured by the platform itself is in fact an artifact of the restrictions associated with the platforms. Because most of the functionality has to be built into the platform itself. If you look at, in the case of Ethereum or Solidity, almost all of the features and functionality there are restricted within what you can do within the bounds of the EVM. The EVM is essentially the ultimate arbiter that says this is what you can do, and anything that's not sort of not compatible with it cannot be done inside of it. I think this is why you see, separate projects like Chainlink and all these other things that are dealing with integrations across it, because if you can't do something within the bounds of the EVM, you cannot do it at all. It's sort of the reason why the EVM itself has become so valuable. I think there are exceptions to this. You look at Uniswap capturing massive amount of fees, all the other DeFi products, which are the highest value captured by applications are sort of these narrow DeFi products that they fit within the bounds of this operation, but they themselves are relatively restricted. I think if we're talking about sort of more complicated applications in the future, part of the answer here is to look towards a conventional paradigm, which is that the sort of protocol layer should not have sort of all of the responsibility. I think, if you look at a conventional internet stack, most of the applications that are built on it can be vastly different. They can have huge amounts of customization and different different functionality. I think people have made the analogy with email before, when talking about decentralized systems and crypto and blockchain in the past, where the email protocol, you can have any number of email clients, you can have any number of level of customization on top of that. And the approach we're taking nowadays is you have this one platform, it has a execution environment, it has a fixed SDK you can build against, you upload your artifacts against that, and it only works within that system, which I think is sort of analogous to, the equivalent of a Facebook platform where it can't communicate outside of that. And you have to have all these, sort of, ridiculous bridges, almost like matrix bridges, between each one of these little walled platforms. And that just doesn't seem, it doesn't seem like a decentralization effort. It almost seems like a failure of centralization within one of those areas. And I think I'll say that I'll trace this issue directly back towards the sort of limitations of executors. I think in a perfect world, if all the known problems had been solved, if we had these sort of perfect environments like WASM that could handle oracles, if we had much more complicated executors, a lot of this behavior would be lessened in impact. But the fact is we don't. A lot of customization and code portability is not easily jammed into one existing platform. There's not even an agreement on what the proper execution environment is for a lot of these things. So I think really the effect you're seeing here, where it's very difficult for applications to capture this value that is obviously there over the platform itself, is sort of directly connected to the limitations and difficulty in the platform in expressing all of these things.
So Ryle, just for everybody that's on the call, essentially what you're trying to preface is that why we're not seeing Web3 applications composable with Web2 and the internet is because they're almost creating siloed Facebooks, if you will. And thus, like, you can't communicate outside of Facebook. So why would Web2 digital infrastructure be able to communicate with Web3 digital infrastructure? Is that kind of right?
Yeah, it's basically like if you commit to using Ethereum or some other chain, you're locked into their execution environment. It's a custom code. I really think portability of these things is going to be sort of the future between execution environments that are much closer to conventional code. I think the general trend towards WebAssembly has been pulling separate code from different languages, but I don't think it's really sort of there in the sense that you can take an existing project that uses conventional programming languages and quickly guarantee remote code execution across different environments. I think the sort of ultimate pipe dream future is where that's all handled automatically. But I think sort of in the interim, we need sort of a different approach for handling that, and trying to shift more of the responsibility of the protocol down towards handling interop layers and give the applications essentially more power and flexibility for customization. So I think the sort of immediate answer to this is giving applications more ability to dictate operations, and viewing protocols more as translation layers between separate applications, where the protocol can grow over time to encompass these sort of different behaviors in terms of rerunning and re-executing code. But that's bounded, purely by the execution environments that are available, and sort of not application specific level code. And I'll go into that in more detail. So again, I've seen, one of the biggest questions I always get is, so what is the product? What is Constellation doing? Why are you doing this? What is the justification behind it? And I think it helps to sort of fit this narrative into existing products and existing projects that are in the decentralized space. Because I think I've seen this many times before. There's sort of a distinction where, when you're talking about, Hyperledger Fabric or any of these other sort of framework approaches, or things that touch on-prem deployments, or, some of the case studies from Walmart or any of these other examples where they require an excessive amount of customization. I think this also touches, Oracle platforms and things like that, where they deal with code that can't be run through a conventional SDK or a conventional executor. All these things are sort of grouped into a separation of something being viewed as an extensible framework versus, uploading fixed artifacts and binaries. So, most of the original Notion has built off of Bitcoin scripting language and viewed every single operation as a fixed binary that you're uploading. Like, you have some script, you're pushing that script in there. And I don't think a lot of people really sort of think about the ramifications of this and compare it to a conventional product. We're talking about a lot of these things as applications, but this sort of heavy restriction here is, creates a lot of penalties and costs. You'll see that in, admin keys that are ad hoc deployed to some of these contracts that allow upgrades, or, applications requiring regular upgrade patterns, or all these other sort of limitations associated with that that have led to this is not sort of us individually saying this. There's a large number of different products that have viewed this, the solution to this as an extensible framework approach, where you are, building a customized application that is distributed, sort of almost the equivalent of releasing a separate fork of Ethereum that reuses a lot of the functionality, but has its own customization, its own extension that follows a conventional programming pattern. I think if you told if you told an app developer and they knew nothing about crypto, and you weren't describing to them a crypto problem, you were telling them they needed to build something out, and you told them that here's a database, let's say they were using a Python script or something, and you told them, here, we've got this big database, and in this big database, I want you to, put a script in Python, and we're gonna pickle that script in Python. We're gonna serialize the state of that script in Python. It's a Python class, and every time a request comes in, we're going to deserialize that from the database. Decode the binary artifact. We're going to run some logic, invoke a function on that script, and then we're going to update that, that script's class and update state x equals x plus 1. And then we're going to reserialize that and restore it in the database. If you told this to somebody who knew nothing about crypto or blockchain or anything like that, and they didn't know what problem they were solving, they would look at you and think you're crazy. They would say, that doesn't make sense as an application. Why are we taking the state of this entire thing and reserializing it and storing it in the database? They would think that's a little bit of a silly thing to do from a technical perspective. Now I say that, not trying to take down any of the gains or the sort of, beauty of Bitcoin and Ethereum's platform in terms of offering a real solution, but more as just, viewing this in a different perspective. I think a lot of these, sort of problems have happened because of some of the limitations associated with executor environments. It makes sense if you don't have to think about the problems of distributing the code to different people. It makes sense if you don't have to think about it from an operational perspective. But again, this is sort of a separate product from what a lot of people view as purely a platform where you upload binaries. I think that is important to make as a distinguishment and to discuss, sort of what the goal of that is. And just to give, context, I think a lot of people get confused because they think, oh, you could compare that to something in, Ethereum or another platform where you are essentially proposing some hash, and then, you have a, local process that proposes a hash to something that undergoes consensus, and that operation is sort of the equivalent of an extensible framework approach. I think you can consider these sort of one-to-one translations where if you had a separate sidecar process that was running some custom code that takes this hash, pulls in a bunch of data, does some sort of calculation on it, and then re-uploads the hash to a process that undergoes consensus and say, do all the peers agree that this hash is correct? That would be essentially the same thing. There's no essential difference other than the way the sort of code is organized. That makes it a lot more complicated. You'd have to have inter-process communication calls. You'd have to have something that is essentially triggering on every consensus round, waiting for some value to come in and checking it against an external service. And that's how most of these oracles and bridge operations are constructed. We'll talk more about the sort of difference between light client validation and things like that. But the ideal future is where you could write this more closer to a conventional application. You can import these consensus primitives, and you can sort of deploy an entire customized application that has so maybe logic that will not fit in a different SDK or a different platform. And it can sort of exist as its own independent application that has all of these sort of bridging functionalities and connections to other networks sort of built in or baked into it. The goal is really to make that as easy a process to use as possible that gets around some of the existing limitations. And you know, again, as part of this, we don't want to sort of throw out the baby with the bathwater here, right? Like the goal, you know, the most obvious criticism someone could instantly make is, okay, you know, you have an extensible framework, framework. Doesn't that just mean I've started up a completely separate and new network every time? And the answer is, you know, depending on the configuration, yeah, if you didn't connect it to an existing network, if there was no translation layer, if there was no way to run or execute or validate code, then yes, it would be a completely separate network. But that's not sort of the goal. The goal is to sort of, you know, gain the best of both of these worlds. And you know, when I say that, I mean to have a sort of, you know, system that connects the flow and application logic towards, you know, whether or not portions of it are validated or not. And I would say that's exactly the same model that you see in bridges and Oracle operations, where, you know, it requires us to sort of break up an application into portions of the data flow that can be considered validated and secured by multiple parties, irrespective of whether or not they're running the platform, versus portions that can't. You know, imagine I have some many-stage pipeline where I am talking about, you know, I have a data input source that is, you know, the price of Bitcoin or something, or I have to, you know, query from an external source to get it. It's something that's a non-reproducible or code customized source of data. And then I have a function that takes that non-reproducible data, something that requires a framework approach to handle. And then I have some function that takes that value and does +1 to it. Well, you know, if I have a single platform, I would have to split up the code in this sort of horrifying way where, you know, I have an inter-process communication call that does one of these things. I then take the value of, I decode it. I have a separate fixed smart contract that does that. I feel like, you know, a lot of those steps should sort of be automated, where the +1 operation is something that you can reproduce. It's something that you can gain the security of as many peers as possible that run the common translation layer in order to gain validation of it. The initial operation, it is not easy to reproduce. It requires a peer subset that is for running specific separate code. And this is essentially exactly the same issue you run into with bridges. So the current patchy fix for this problem is essentially you have, you know, I will say there are, you know, some of these, you know, zero trust bridges, which essentially, you know, it's a little bit of a marketing term in the sense that it's zero trust because it relies on a peer subset. If you have one of these bridge operations between two nodes, you can have some of the actual logic and state recreation logic embedded in the contracts and fixed contracts, but you're still fundamentally limited by the peer subset that knows about the code of each different network. To get, you know, sort of a perfect bridge, you need a node running both networks' versions of code. And those things are subject to hard forks, they're subject to updates, which means you need them to keep those things up to date. Even if you have a fixed contract associated with it, there are some that I've seen that, you know, deal with light clients that are embedded inside the contract. That still runs into the same problem of you need that light client to query another peer subset. So every single one of these falls into the same security model, which is you don't have a one size fits all. You do not have every node on the network validating every single piece of data. You have a fractional approach where there are different groups of peers that have validated different groups of data. And your security model changes now into something closer to a marketplace. So rather than a, you know, single source of security, you have, you know, different groups of peer subsets representing or spanning different validation criteria in terms of reproducibility that, you know, essentially offer the security model. And I think that makes more sense to bake into the sort of protocol layer, where rather than, you know, sort of have all these asterisks or addendums saying, you know, well, this bridge is perfectly secure, you know, with an asterisk saying, you know, not all peers have validated it. It should really be built into the protocol sort of in advance for designating stages of these operations that fall under this sort of framework approach versus those that fall under the sort of completely reproducible approach. I think that also offers stronger scaling guarantees when you're talking about the fact that, you know, the sort of inclusion of data into a single hash reference, you know, a compounding hash reference, creates this situation where you have, vast, fee explosions during periods of time. And I think it sort of makes more sense if you're thinking about it as a sort of pub sub model, which really, reflects the current phenomena you see, where there are potentially many different applications. You might have a file coin, you might have an execution coin, you might have dozens of different networks involved in a more complicated stack. And each of those is essentially following a pub sub approach for who the peers are validating, which means there's not a single source of security. It's essentially closer to a market where you have multiple providers of security, you have people bidding on the security and sort of ranking that, as opposed to a walled garden of security where you have essentially one group of peers that has decided everything falls under this exact security model. This is sort of why you get a new network spawning up all the time, right? Is because that model does not account for creating a market for security.
So, just to kind of take a moment for the community to kind of understand what Ryle's talking about, is really kind of addressing a question that many people out in Twitter are saying, like, oh, haven't we heard enough from enough infrastructures and new networks? And we keep seeing all these new networks, and it seems like they're solving all these scalability problems. But a lot of what Constellation goes back to the core is that we believe that immutability and auditability needs to be the core of every tech stack. And in order to do that, you can't use what existing networks are doing today. This is also why we're not seeing true composability. And this also really opens up to what Constellation is doing different and how we see the world, that everybody should be able to use a blockchain-like feature and functionality inside of every piece of programming that they're doing. And this is our approach into kind of realizing those tools and infrastructure layer tools that developers can do. And so, kind of segueing a little bit, is that I wanted Ryle to really talk about some of his work with the Department of Defense, and really kind of what that demo looks like. He was the one kind of guiding them through the process, guiding them away from the correlation between us and Ethereum, and really showcasing our consensus mechanism and really our approach, and why we are the only ones doing what we're doing at the Department of Defense level.
Yeah, so again, I can't talk in extreme detail other than to sort of highlight the sort of general product area that some sort of on-prem deployment requires. I think a lot of people fall into this exact same situation, where there are lots of big businesses that are interested in sort of gaining the security benefits. I think in this case, the desire for security is sort of a lot higher than a customer like Walmart or some other large corporation. The security emphasis is just sort of overwhelming, and it's a
fringe case. It's a very fringe use case, but yet some of the functionality and what we built with them can be applied to really any business.
Exactly. I don't want to talk about any specifics associated with their sort of internal deployment or their use case or anything like that. But from a product perspective, I think there's a ton of people that are interested in this problem, which is essentially having, hybridized style networks, which is something that it doesn't really fit into a walled platform sort of use case. That it is much closer to the phenomenon of bridges and peer subsets, where you have some validators that are operating that are going to be the only ones that can possibly validate some piece of data, but they're the only ones that can validate some piece of data in a large pipeline of data. And that means, essentially, you're trying to span on-prem nodes that can validate certain portions of data. You want security and decentralization even within that on-prem subset. You might have sort of external vendors or external partners or external integrators that you also want to connect with, that you also want them to run some sort of validation, which may overlap to some degree, but not overlap on every operation. And you have lots of non-reproducible consensus elements. So this means large numbers of integrations with sort of internal products, internal systems, internal data that all matches sort of Oracle patterns, or things that rely on REST queries, for instance, that are extremely difficult to guarantee you have a layer of determinism associated with them. That essentially require some sort of framework model, but then they also need to connect to other internal applications that do not fit into that, like fixed executor contracts that are going to run across and between these sort of nodes. I think that makes it a lot more advantageous to view this as something that is a pipeline of many steps, some of which are reproducible, some of which are not, and that integrate and connect with other decentralized systems. I think some of the major requirements are around per file permissioning, so that different peer subsets can act as validators to different operations. You need to have integrations with IPFS-like storage that has additional encryption layers on top of it. So it's much more complicated than a simple operation like that. Again, we want it needs to have potential integration paths to other networks that can support sort of different kinds of network contracts and fixed operations at the same time as supporting a framework over these sort of custom data types. I think one of the things that's most important of all to them is that from a security perspective, proof of stake is completely meaningless. It has zero meaning. If somebody bought up all the network, they're not going to care who that validator is, right? Like, it's complete. Like for the portions that deal with some of the hybrid integrations across external vendors, there's an argument there that it could be made that some of those vendors might, there might be some way you can deal with the contracts associated with that. But as a security model, it just really sort of doesn't hold up. And then proof of work here is also completely unusable if you're talking about something that has lower latency requirements, lower computing requirements, or has to scale much larger. Telling them that we need to create sort of an internal arms race for an on-prem deployment is just a non-starter. So this leads us into the sort of model that we're presenting them, which is the model that we're using internally, which is individual peer score assignments, which are known as reputation or trust models. So I'd say this is definitely something that is interesting to people who are dealing with on-prem or don't have a meaning of a proof of stake or a proof of work. I think it sort of exhibits it as being extremely more important and sort of more fundamental than what is going on, which gets into and this ties exactly to what we were talking about earlier with this break of considering everything associated with a single peer subset. I think a lot of that makes sense. And, a lot of proof of stake thing has, apart from the edge cases where you have somebody who owns 90% of it or whatever, even the smaller edge cases get into the question of, how do you deal with that across a bridge, right? If you have different peer subsets, how do you deal with stake across that? Like you could just have a fracture across that, and then the sort of stake is meaningless. You can have mutual deposits across it. It gets into super complicated scenarios. I think what makes sense is to sort of take a step back and ask the question, like, how did these products get released, right? I think, Vitalik has said many times, the underlying security mechanism against a failure, even in proof of stake or a software code problem, is social proof, right? So you have, if you're trying to figure out what Ethereum, I'm sure there's tons of Ethereum hard forks out there that represent, scammers trying to convince you that this is the new Ethereum network. I think a lot of people will check Twitter, check Vitalik's statement. What is the current active Ethereum hash? What is the current hard fork? What is the current software version? None of those questions are answered by proof of work or proof of stake. They're a step that happens before, right? The question of, if we're doing a hard fork, who is deciding what that hard fork is? That's a social proof question. That is a sort of random, organization of people deciding to run different nodes. And there is zero automation behind this. There's zero modeling. There's the opportunity to introduce attacks and things like that. Really what they're replicating is a process that happens internally where people view the existing peers that they know that are relatively well known. They'll go and check, but they'll check the GitHub, they'll check Vitalik, they'll see who's contributing to the project. They'll make sure that they're on the correct fork by comparing it against peers that they already know, which means there is an implicit model happening right now where people are not checking, does this person own a certain amount before I join this network? No, they're looking at who this person is. They're going to join that peer network based on what what other people have said. That's the underlying security phenomena that protects most of these networks, even if you're not considering the short-term case. And I think that is actually more important for us to consider and build on, because it affects these edge cases where you're talking about the DoD or somebody else who has a more complicated security model. So we want to sort of try and capture that information as web of trust. There have been other projects that have attempted to sort of capture this and tie it to crypto keys and things like that. And it's sort of a relative peer assignment that is designed to replicate that process where these fork decisions right now, they're manually determined a lot of the time, where you're deciding between hard forks. And we'd like to, sort of make that's a relative process where somebody is, assigning their internal scores. I trust Vitalik, I'm going to go with whatever hard fork he says, rather than sort of assigning that and then determining transitively what is the most sort of accurate network. I think a lot of that is important for automating this, because it allows a large flexibility in the actual models that are chosen. You can capture all sorts of off-chain data. You could, automatically assign based on IP ranges or spammer likelihood, or connect it to any of the other reputation systems that establish, real-world identity with ZK proofs and any of these other systems that have, Twitter verifications, they have social media proofs, verifications, all of that can feed in as Oracle information that connects to a primary model. And it also allows us to capture a source of determinism, which we can use for tie breaks in the event that there are conflicts generated that are not actual conflicts, but just sort of minor conflicts.
So next slide.
Yeah. So I think we can move on.
Yeah. So to kind of summarize a lot of what Ryle's talking about and kind of leading into are the thoughts that we have, and what we're building behind the scenes is something that is truly extensible. And working with the DoD allowed us to kind of see a very complex and fringe use case and then work backwards. We knew what the customer wanted. It was a very extreme use of our network, but that's really what we want to be able to showcase, is how complex or as how simple that we can actually really make this. And so all of our work is kind of building blocks on one another, if you will, all the way down to the consensus level and what that can be used for, and how extensible and how wide and vast we can use this system for. It's pretty amazing the work that they've put forth over the past 3 years in working with the DoD. And so I'm going to give Ryle a second to take a drink of water and maybe even catch his breath. You can tell his passion and as much research as he's done across really any blockchain out there, and really what they're missing. Once again, I think you can start to piece together why we are so different in the lens of the DoD, and why they're leaning on us to produce such a complex system that's really never been invented today. And so in shifting gears, Ryle's going to come back in a second to really show how all these building blocks come together over the course of the next year. So in this slide here, we presented this roadmap a little earlier this year. I think we did this in July, talking about the multi-phase approach into releasing our new technology. We've completed the testnet phase. We've completed the phase 1. And now we're kind of opening up our roadmap for 2023. We've heard a lot of criticism from the community that we didn't put dates on there to give us a little bit of flexibility. And so now Ryle's going to walk through 2023 and how both phase 2 and phase 3 come to life over the next year, starting with Q1 of 2023. Ryle, do you want to walk them through the next year and what you have planned?
Yeah, absolutely. So I think the sort of first thing that makes sense to show off from a framework perspective, which is a lot of what we've been working on, is reusing the sort of existing functionality we have in the currency. So this L0 token standard is designed to sort of build out something that can be used sort of instantaneously to really showcase a lot of the existing work that has been done before. In terms of offering a currency and making sure that everything we're doing is essentially reusable, modular, and can be extended into more complicated application use cases. The other portion is, essentially adding internal wallet support through Rosetta. I think we have some operations that are supported right now from the CLI from a wallet perspective, but this is not as sophisticated as in what you would expect from Bitcoin CLI. I think Rosetta has offered a nice standard for interacting and integrating with other products, and we would want to sort of start getting experimental support for that. And maybe not all the features of it are supported. It has a large number of features attached to it, but just sort of the basics around being able to construct transactions relatively simply from a REST API. Which will help out a lot with the integrations and operations like that. I think the next sort of operation of that, after logically, extending the work we have done already with a currency to make that into a framework so that anyone can use and anyone can start a currency based off of that, is really to start extending into more complicated applications. So I'll discuss in more detail what we mean by ACI or application chain interface. And the sort of translation layer that we're planning on building, and the sort of reference applications. But this is basically, focused entirely on, simple reference examples and state channels that offer some functionality that show how to extend, instead of using just a currency, to extend it to different more complicated consensus use cases. And these are sort of the building blocks that you would need to pull in your custom code, where you can offer a custom application that has some functionality that you can't find on a conventional platform. And I think this sort of ties in later towards building out this translation layer in more detail, offering more more use cases that mimic common functionality, and sort of extending from a series of logical building blocks, so that all of these things are relatively easy for a developer to find some existing example, find something that matches what that is that they're trying to build, and have a sort of a simple way to copy and paste some example and extend it further. And we'll go into this in more detail on one of the later slides, what we're talking about with the ACI. The other sort of major operation as well is sort of extending the model and enabling it more. I think so. Right now we have the existing model in place, but it's not used in every area, and we're trying to sort of ensure that it has more of the network can be opened up. And I think that's a long, gradual process where we need to sort of move slowly and ensure we have large amounts of tests and verifications that everything is working as expected, and sort of a series of security steps where we're testing the network to against various attack scenarios. So I think that is a sort of gradual process that will expand out over time, but hopefully we'll be able to start showcasing some of the usage of the model.
Yeah, thanks, Ryle. I think this roadmap is pretty detailed, and we're going to go into what an ACI is, what an executor is, get the details of what that really means. From a high level, what this means is that we're starting with early developer adoption, very simple currency frameworks that people are familiar in, but want to build it on the Hypergraph. And then during the course of the next year, you're going to see a lot more deployments, more documentation coming out, more governance proposals on things like state channel requirements. And we're going to see that evolve through governance. We'll also see it evolve through documentation, and we'll see more use cases that handle more complex operations that Ryle's talking to, and really kind of use our protocol to the extent that we think it can be done. This is a very powerful year. A lot of stuff is happening and getting deployed in the course of just 1 year that really kind of will have that snowball effect and create that viral adoption that we're aiming for. So to kind of break it down, our first, what we just highlighted on Q1 2023 is really around our SDK features. And what can people expect with the new SDK coming up in Q1?
Yeah. So I think, one of the biggest issues is just sort of a clarification around what is an SDK, what is a framework, what is an executor SDK. I see this question all the time. Everything that we're working on in my mind is sort of a portion of an SDK. It's something that you can pull in as code that you can use in different aspects. The portion that we're working on most immediately to offer is the one that offers the most customization, which is the ability to extend consensus as a framework, pull in custom code, pull in REST API queries, whatever sort of customization you want around that is what we're trying to offer as the initial set of applications, because it offers this tremendous level of flexibility versus sort of fixed executor contracts. The Executor SDK that we're working on, the main goal initially is to offer this as a translation layer between these separate applications. So for things like functions of +1, that is something that is so obviously translatable between different applications, it doesn't require any customization, that we would view that the executor operations as being some way to internally take one of these framework style applications and be able to translate schemas and functions between them when they fall into a common L0 layer. The goal of that, distinguishment, it still requires a portion of the SDK. It would essentially be part of the main application. It would also offer sort of, fixed executor contracts in addition to this sort of translation layer. So again, the main sort of offering or immediate release in the future is around the currency framework SDK, which is going to support, the exact same standard that we're offering. It will offer updates and upgrades that are consistent with our network. We're hoping to eventually extend that functionality to all the other integrations that we're offering, and regain all the functionality that we have invested time in supporting this currency to anyone who wanted to launch that. And anyone who wants to launch that would ideally be expecting an upgrade path to using this so that you're not locked in and you can sort of continue to take this as the initial example that connects you to the network and extend this in the future to more complex use cases. So again, this would act as a reference implementation. There would be documentation and onboarding guides that would allow you to sort of use this instantaneously, and we'd expect that to logically translate into the next level of customization and specification to your application.
Just to quickly jump in on the currency framework, I just want to sort of underline it at a high level, because it is pretty exciting, and it's one of the next major features we'll be releasing. So the currency framework is the first iteration of the SDK. So if you see you saw the SDK on a previous roadmap and you don't see it now, that's the currency framework. And so it's aimed at currency use cases, obviously. And so this is going to be the base that will allow L0 tokens to launch. And like Ryle was describing, it's one of the core ideas behind it is that it needs to be extensible and upgradable. So there's always an upgrade path. It'll be locked in. If you start building early with kind of a limited subset of features, there's always an upgrade path to get to the later features that are released. So yeah, I'm personally super excited for this release. We'll be ready for the first Pioneer state channels to build, and just excited to see what everybody builds.
Thanks, Alex. Appreciate that.
Eric Carson.
Sorry about that. Ryle, do you want to jump into kind of the protocol interdependencies?
So I think, everything I've described requires sort of a very large amount of, different moving pieces. I think, going forward, some of the biggest focus is going to be around executors and the translation layer. So this refers to, some way to deal with the portions of customized framework code that do not, that can actually be translated among each other. So again, this is the portion of a pipeline where it can be shared easily, as opposed to the portion that cannot. And the other aspect is sort of usability. I think we want to sort of approach this as like an HTTP4S like builder pattern, where you are if you want to add a currency, it's sort of the equivalent to adding a route in an API. Obviously, there's more level of complication there. If you want to add some other sort of common Lego building blocks to your application, these would appear essentially as a builder pattern where you can extend it further based on custom data types that are specific to your application. And again, all of this would sort of be in the view of a microservice API, where your application is viewed as a service API. And there, we would expect them multiple peers to be running multiple different applications, similar to a service mesh. And we want to distinguish what application inputs require validation. So again, all of this is really all about specifying what portions of your application are going to be required, and specifying what portions of your pipeline are going to be required for different steps of validation. So the whole goal is to sort of introduce interop layers and introduce API equivalents that we're calling ACI to distinguish, sort of what operations are chain related versus what operations are, essentially simple modifications of the existing state of the application. So next slide. So again, for this ACI thing, I think the sort of logical analogy here is for common translation layers. If we're talking about a currency in terms of an application chain infrastructure, the analogy here would be to some commonly used API. If we have something like Bodo or the S3 API, this is used or implemented by dozens of different file sharing and file storage services. It's a common interop layer that is used by many of these operations, and the request and schema types associated with that are all sort of well known and well established. I think the distinguishment here is that each application might want to have more of the surface area of its API used for mechanisms that are, sort of reading state or reading data out that is sort of, not necessarily important. I'd say the distinguishment here between an ABI is that we're only really interested in capturing things into the ACI that need to undergo validation or need to undergo security. So where it's something like, you have some specific state embedded in here, your application might want to offer a more complex API, but it might not require that level of sort of re-verification on the read side. On the write side, for the inputs, for an ACI, we need to distinguish data that needs to undergo chain interaction. So, this would be the equivalent of a sort of redeem operation or deposit operation or any other operation that needs to undergo consensus under chain data. That is what needs to be sort of captured by this chain interface, and it should match what a microservice API looks like, except having data types that are specific to requests that need to undergo consensus. And we sort of obviously want portions of those to match this S3 pattern, where if you have a large number of L0 common data types, your application would be able to automatically connect and handle validation for any other application that's using those common data types.
I'll hand it over. Thanks so much, Ryle, for giving over that clarity on the ACI, executors, the SDK, and the roadmap. Ryle's going to be doing a, Twitter Spaces with the DAG Chads later today. He'll be doing that alongside Wyatt. To really go into what does all this mean and how do I start using that when I'm designing an application. Now I'm going to turn it over to Alex to really talk through what this means for the developer ecosystem and what type of support we're going to offer the developer ecosystem and what to expect.
Yeah, great. Yeah, so I guess first, what is a developer ecosystem? What are we talking about here? Talking about the ecosystem of developers that's building apps on top of the network. And in a lot of ways, they're responding to these protocol roadmap features that that we've been talking about today. So I think we're going to see the number of ways to build on the network and participate grow quite a bit this year. So just want to kind of give a little overview of what's happening now and what we can expect over that time period. So the first thing is multiple token standards. I think in the past, a lot of the time when L0 tokens were talked about, we're talking about it as sort of a singular token type, a currency style token, something like an ERC20. We should really be thinking about multiple standards, token standards for different use cases. So, currency use cases, identity, multiple types of NFT use cases. We're gonna be seeing those sorts of standards come through our governance process, so that it can be kind of discussed with the community and adopted if it passes that process. So the next thing, maybe this one's obvious, but we're going to see support for L0 tokens being added to ecosystem applications. So L0 tokens are going to be supported in DAG Explorer, Stargazer Wallet, and developer packages. We're also going to see those developer packages expand to cover more languages. Currently, we've been focused on Scala on the protocol side and TypeScript, JavaScript on the kind of userland package side. We'll see languages like Python, Golang, potentially a few others have developer packages added, so that you can use the language that you're familiar with to build on top of the network. And then this one I'm particularly excited about. We are opening up a new position on the core team. We're calling it developer advocate. And so this is a person that's going to work directly with developers in the community to create tutorials, example apps, make sure documentation is up to date and accurate, and then communicate directly with developers through Discord, through Discord, Telegram, whatever channels they're using, and just really open up a line of communication between developers working with the network and the core team, so we can have that feedback loop. So the question is, how can you contribute? Really, the best way to contribute is to build something on the network. So that may be a state channel if you want to build a state channel, but there are a ton of other projects that you can take on working with the network. We encourage you to use the Stardust Collective open source projects as a guide or a jumping off point. So that's DAG Explorer, Stargazer Wallet, DAG4JS, a few others. The complete source code is available. You can go and make a pull request if you want to add a feature, or you're welcome to fork it. You can copy, borrow, steal, whatever you want. Create something new with the code, and feel free to reach out to us on Discord, and we'll help you however we can. The ultimate goal is to have multiple competing wallets, explorers, projects. We'd love to see the community projects pop up. So we definitely encourage you to do that, and we're happy to help however we can. If you would like to make any changes to the core protocol, that's the Constellation repo. The best way to do that is going to be to submit ideas through governance. At a certain point along the way, that's going to require a reference implementation, and then that'll kind of give the proper place for discussions to happen around that feature, and if it's something that the community wants to adopt. If we jump to the next slide here. So I just wanted to give a quick shout out. We have some open positions on the core team. So if this is something that interests you and you have the right skill set, we'd love to hear from you. So that we've got protocol engineer openings. So the skill set there would be functional Scala, distributed systems background, and full stack Web3 engineer. That would be primarily working on Lattice. So that would be a JavaScript background, React and Node.js. We have product manager role open, also working on the Lattice and Stargazer. And then a couple of roles open in governance. And those would be, working to facilitate ideas through the governance process, get ideas from the community, into a position where they can be fleshed out and then voted on by everyone. So if any of that sounds interesting to you and you think you'd like to give it a try, definitely check out constellationnetwork.io/jobs and you can apply there.
Thank you, Alex. That was awesome. Exciting to be building out the team. This is really the time now for us to really scale out this company. The tooling's there, the foundation's there. We're ready to blow up. I'm excited. This is awesome. Great work on this, Alex. Ryle, thank you so much for giving your overview, talking through design choices, the protocol roadmap. Always impressed by what you guys are building and the thought behind everything. I think we're ripe for a really, really big 2023 with massive scaling opportunities. So thank you all. This was an exciting Hypergraph hour. I know I didn't get to say much. I didn't need to say much. I did my piece last week, but these guys bring a different perspective, show you what's going on behind the scenes, and really how to participate, follow along, and get going. So if I don't see you all before now and the end of the year, have amazing holidays and a happy new year. Look forward to growing in 2023. Thanks, guys.